This is SpaceTime Series 25, Episode 56, for broadcast on the 18th of May, 2022. Coming up on SpaceTime, the biggest Marsquake ever recorded, NASA's Psyche mission moves a step closer to launch, and a survivor discovered in a massive supernova blast. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have detected the biggest Marsquake ever recorded on the red planet. The seismometer aboard NASA's Mars InSight lander recorded the magnitude 5 trembler, the largest quake ever observed on another planet, on May the 4th, the 1222nd Martian day or sol of the mission. May the 4th be with you indeed. This latest event adds to the 1,313 other quakes InSight's already detected since landing on Mars back in November 2018. Scientists are still sifting through data from this event, which followed two earlier large Mars quakes, a magnitude 4.2 recorded on August 29, 2021, and a magnitude 4.1 recorded some 24 days earlier. Each of these events was some 5 times stronger than the previous largest event recorded on the red planet. The two 2021 events reported in the journal Seismic Record were also the first recorded Marsquakes to have occurred on the far side of the planet from the lander. And seismic wave data from these events could help researchers learn more about the interior layers of Mars, especially about its core mantle boundary. Scientists were able to identify reflected PP and SS waves from the magnitude 4.2 event, which is known as S0976A, and they located its origin to inside the huge Valles Marineris Canyon system. The massive Valles Marineris runs like a deep split in the planet's crust along the Martian equator east of the Tharsis region, and stretches for nearly a quarter of the way around the Martian circumference. It dwarfs Earth's Grand Canyon and is one of the largest rift valleys in the solar system, more than 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep. Earlier orbital images of cross-cutting faults and landslides suggest that the area is seismically active, but the 4.2 event is the first confirmed seismic activity there. Meanwhile, the magnitude 4.1 event, called S1000A, was categorized by reflected PP and SS waves as well as P-diff waves, small amplitude waves that traverse the core mantle boundary. This is the first time P-diff waves have been detected by the InSight mission. Researchers couldn't definitely pinpoint S1000A's location, but like S0976A, it originated on the Martian far side. The seismic energy from S1000A also holds the distinction of being the longest recorded on Mars, lasting some 94 minutes. Both these earlier Marsquakes occurred in the core shadow zone, a region where P and S waves can't travel directly to InSight's seismometer because they're stopped or bent by the planet's core. PP and SS waves don't follow a direct path, but rather are reflected at least once at the surface before traveling to the seismometer. One of the study's authors, Sava Salen from ETH Zurich, says recording events within the core shadow zone is a real stepping stone for science's understanding of Mars. Prior to these two events, the majority of seismicity was within about 40 degrees of InSight. Being within the core shadow, the energy traverses parts of Mars scientists have been unable to seismologically sample before. The two earlier Marsquakes also differ in some important ways. The S0976A, that's the magnitude 4.2 quake, was characterized by only low frequency energy, like many of the quakes described so far on the red planet. While the S1000A, that's the 4.1 magnitude wave, has a very broad frequency spectrum. The S1000A was a clear outlier in the Mars catalogue, and it will be key to science's further understanding of Martian seismology. Also, the S976A is likely to have a much deeper origin than the S1000A. The latter event had a frequency spectrum much more like a family of events that appear to be shallow crustal quakes. So this event too may have occurred near the surface. Also, S0976A looks like many of the Marsquake events that have been traced to the Cerebus Fossae region, an area of extensive faulting that has depths modelled to be around 50 kilometres or more. And it's likely that this event may have also had a similar deep-sourced mechanism. Compared to the rest of the seismic activity detected by InSight, these two far-side quakes stand out as true outliers. Not only are they some of the largest and most distant events ever recorded by quite a considerable margin, but S1000A has a spectrum and duration unlike any other previously observed. So they truly are remarkable events in the Martian seismic catalogue. This is SpaceTime. Still to come, NASA's Psyche mission moves closer to launch, and a survivor discovered in a massive supernova explosion. All that and more still to come on SpaceTime. NASA's Psyche spacecraft is now undergoing final processing at the Kennedy Space Center prior to its launch to the asteroid Psyche, slated for August. Since its arrival at Cape Canaveral last month, the Psyche spacecraft has moved into the Payload Hazardous Servicing Facility. There, technicians removed it from its protective shipping container, rotated it to vertical, and have begun the final steps to prepare the spacecraft for launch. In the coming months, crews will perform a range of different work, including reinstalling the solar arrays, reintegrating a radio, testing the communication system, loading propellants, and encapsulating the spacecraft inside its payload fairing before it leaves the facility and is moved to the launch pad. The Psyche spacecraft will explore the main belt asteroid 16 Psyche, which circles the Sun between the orbits of Mars and Jupiter. The 220-kilometre wide metal-rich M-type asteroid is composed largely of nickel and iron, and that suggested that it was the remnant of a core of a protoplanet that had somehow lost its mantle and crust. However, more recent mass density studies have raised some serious questions about that hypothesis. The Psyche spacecraft will launch aboard a SpaceX Falcon Heavy rocket, that's 3 Falcon 9 core stages side by side, from Launch Complex 39A at the Kennedy Space Center, arriving at the asteroid 16 Psyche in 2026. Once there, the spacecraft will spend at least 21 months orbiting the asteroid, mapping and gathering data, and potentially providing insights on how planets with metal cores like the Earth are formed. But more likely, it'll simply be discovering what makes this asteroid so different and apparently inside out. Basically, is Psyche the stripped-down core of a differentiated planetesimal, or was it formed as an iron-rich body? Differentiation is a fundamental process in shaping many asteroids and all terrestrial planets, and direct exploration of a core could greatly enhance science's understanding of these processes. The Psyche mission will characterize the asteroid's geology, shape, elemental composition, magnetic field, and mass distribution, thereby increasing science's understanding of planetary formation and structure. The spacecraft's primary science instruments include a multispectral imager to provide high-resolution images using filters to discriminate between metallic and silicate constituents. There's a gamma-ray and neutron spectrometer to analyze and map the asteroid's composition, a magnetometer to measure and map the tiny world's remnant magnetic field, and there'll be an X-band gravity science investigation which will use the spacecraft's X-band microwave radio telecommunication system to measure the asteroid's gravity field and help determine its internal structure. This report on Psyche from NASA TV.
There aren't many classes of objects left in our solar system that we haven't looked at up close with a spacecraft. And one of them that's left is the metal asteroids.
16 Psyche is an asteroid that orbits the Sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich. It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do. And it would be the first metal object that humankind has ever visited.
We've been approved to go in August of 2022. It'll take a number of years to get there.
Flies past Mars, gives us a gravity assist, uses our propulsion system to then slowly creep up toward the end of 2025, getting there in early 2026.
We'll go into 4 concentrically smaller orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma-ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we are continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic, too, when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
And in that report from NASA TV, we heard from Psyche Deputy Principal Investigator and Image Instrument Lead Jim Bell from Arizona State University, Psyche Gravity Science Investigation Lead Maria Zuber from the Massachusetts Institute of Technology, Psyche's Project Manager Henry Stone from NASA's Jet Propulsion Laboratory, Psyche Project Systems Engineer David Ho, also from JPL, and Psyche Principal Investigator Lindy Elkins-Tanton, also from Arizona State. This is SpaceTime. Still to come, a survivor discovered in a massive supernova explosion. And later in the science report, a new study says 2/3 of Australians now say cigarette sales should be ended. All that and more still to come on SpaceTime. Astronomers have discovered a surviving companion star in the aftermath of a massive supernova explosion. A supernova marks the catastrophic death of a star in a blast so powerful it can briefly outshine an entire galaxy. This supernova event, catalogued as SN 2013 GE, occurred in NGC 3287, a barred spiral galaxy similar to our own, located some 47 million light-years away in the constellation Leo the Lion. NASA's Hubble Space Telescope uncovered the surviving binary companion star, which had previously been hidden in the glare of its partner supernova. The discovery, reported in the Astrophysical Journal Letters, is a first for this particular type of supernova, one in which the supernova progenitor star was stripped of its entire outer gas envelope before exploding. The findings provide crucial insights into the binary nature of massive stars, as well as the potential prequel to the ultimate merger of the pair in an event that will eventually rattle across the universe as gravitational waves, rippling the very fabric of space-time itself. Astronomers detect signatures for various elements in supernova explosions, and these elements are layered like an onion pre-supernova. Hydrogen is found in the outermost layer of the star, and if no hydrogen is detected in the aftermath of the supernova, it means it must have been stripped away before the explosion occurred. Now, the cause of the hydrogen loss has always been a bit of a mystery. Astronomers have been using Hubble to search for clues and test theories to try and explain these stripped supernovae. The new Hubble observations are providing the best evidence yet to support the idea of an unseen nearby companion star siphoning off the hydrogen gas envelope from its binary partner before it explodes. The study's lead author, Ori Fox from the Space Telescope Science Institute in Baltimore, Maryland, says this was the moment they had been waiting for, finally seeing the evidence for a binary system progenitor from a fully stripped supernova. Fox's team used Hubble's Wide-Field Camera 3 to study the region of the supernova in ultraviolet light, as well as searching through the Hubble archives. The authors saw the light in the supernova fading over time between 2016 and 2020. But another nearby source of ultraviolet light from the same position maintained its brightness throughout. This was the binary companion star. Somehow, it had survived the supernova blast. Now, previously, scientists had been hypothesizing that maybe a massive progenitor star's strong stellar winds could blow away the hydrogen gas envelope. The problem is the observational evidence failed to support this idea. So to explain the disconnect, astronomers began developing theories and models in which a binary companion siphons off the hydrogen from the progenitor star. And this new observation is the first evidence supporting this theory. In prior observations of SN 2013 GE, Hubble saw two peaks in the ultraviolet light rather than just a single peak typically seen in a supernova. Fox thinks the second peak was probably the shock wave from the supernova slamming into the companion star. The new Hubble observations show that while the companion star was slightly jostled, it wasn't destroyed. The findings also support the idea that most massive stars form and evolve as binary systems. Unlike supernovae that have a puffy shell of gas to light up, the progenitors of fully stripped envelope supernovae have been proving difficult to identify in pre-explosion images. But now that astronomers have been lucky enough to identify the surviving companion star, they'll use it to work backwards and determine the characteristics of the star that did explode. It's also an unprecedented opportunity to watch the aftermath unfold with the survivor. As a massive star itself, SN 2013 GE's companion is also destined to end its days as a supernova. Its former partner is now most likely a compact object, either a neutron star or a black hole, most likely a neutron star, and the companion is likely to follow a similar route. The closeness of the original binary pair will determine whether the two stars stay together. Now, if the distance is too great, gravitational pull too weak, the companion star will simply be flung out of the system, wandering alone across the galaxy, a fate which could well explain many seemingly solitary supernovae. However, if the stars were close enough to each other pre-supernova, they'll continue orbiting each other as black holes or neutron stars. If that's the case, they'll eventually spiral towards each other and merge, generating gravitational waves in the process. Fox says with a surviving companion of SN 2013 GE, we could potentially be seeing the prequel to a gravitational wave event, although he admits that such an event may still be billions of years away. However, since we now know that most massive stars in the universe do form in binary pairs, observations of surviving companion stars are necessary to help understand the details behind binary formation, material swapping, and co-evolutionary development. Understanding the life cycle of massive stars is especially important as all the heavy elements in the universe are forged in their cores and through their supernova explosions. And those elements make up much of the observable universe, including life as we know it. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New research has shown that blood tests could eventually replace skin biopsies to look for signs of skin cancer. A report in the journal Advanced Nanobiomed Research claims scientists have developed a testing platform which they say can detect the presence of melanoma cells circulating in the blood and determine whether all cells have been removed after skin cancer surgery. The authors say this new work could one day reduce the need for more invasive testing. A new survey has found that almost 2/3 of Australians think it would be a good thing if there eventually came a time when it was no longer legal to sell cigarettes or tobacco in stores in Australia. The findings, reported in the journal Tobacco Control, claims the national survey found that only 16.7% of people thought that this would be a bad thing. Around half of those who responded to the survey said they would support the phasing out of cigarette sales over a defined period of time, with most supporting a 10-year time frame. A new study warns that too much cell phone use could have a negative effect on sperm's ability to move. The findings, reported in the journal Reproduction, Fertility and Development, are based on a Chinese study which analysed the quantity and health of sperm from 1,634 men and compared these findings with self-reported mobile phone usage. They found that daily cell phone use of between 2 and 4 hours could affect sperm mobility, and so they recommend that men of reproductive age avoid prolonged use of cell phones. Well, it's been a big week in technology. Apple have finally discontinued the iconic iPod, 21 years after the revolutionary device forever changed the way we listen to music. The original device was the first in the world to hold 1,000 songs and boasted a battery life of around 10 hours. Meanwhile, it seems NFTs are all the rage these days. Madonna's just launched a series of fully nude NFTs, which include 3D images of a tree growing out of her. And even the Australian Cricket Board are getting into it. The NFTs, that is, not Madonna. Also, global PC shipments have fallen by 3% during the first quarter of 2022. It's the first fall after 7 consecutive quarters of growth, but revenue is still up by 15%. With the details, we're joined by technology editor Alex Zaharov-Reutt from ity.com.
Over most of the 2010s, PC sales were continuously falling. Tablet sales were up and smartphone sales were up and PC sales were down. Now, that changed about 7 quarters ago when we saw 7 consecutive quarters of PC sales increasing. But you have to realize that also coincided more or less with the pandemic. There was a huge rush for people to go and buy PCs to work at home, for their kids to learn from home. People were upgrading older equipment. Now, over the past 3 months of the first quarter of 2022, that's, of course, after the big shopping sales season of the end of the year. Traditionally, sales are down in that time, but we've also had inflation. In fact, even though PC shipments were down by 3%, compared to the same time in 2021, the revenue was up by 15%. And that's because people want high quality machines. The cost of things has gone up, logistics and shipping, all of that has gone up. So, we're seeing the effects of inflation and the effects of people wanting better quality machines. So, whether we'll see shipments continue to fall, I guess we have to wait and see. But this is the first time in 7 quarters that PC shipments have fallen.
I like records and books and physical items. I'm still having trouble getting my head around this idea of having a digital collectible platform, having things that are there in the cyber world and you can look at, but they're not really real to my way of thinking. Help me out here, will you?
Well, this is in relation to Cricket Australia doing a deal with a company called Rario and Block Trust. And they'll sign this deal to connect, they say, to over 1 billion cricket fans globally with NFTs. Now, NFTs are digital collectible non-fungible tokens. And it's like having those collectible baseball cards, but as you say, they're all digital. I mean, they could be lost, deleted, revoked. People have been making a lot of money from NFTs, but somebody just recently put a little green tick on an NFT on one of these platforms to indicate that it was real. And somebody was doing a swap with some very rare NFTs. They put their real NFTs into somebody's wallet, and they basically got removed from that wallet, and the person lost 2 NFTs worth hundreds of thousands of dollars. So, this whole idea of digital digital items with this value. It sort of reminds me of the tulips that infected the Dutch, where they were swapping an entire house for a tulip, and it all blew over. It's like bubbles in the market, and NFTs just appear to be the latest bubble. I mean, at least Bitcoin, in theory, is rare, has a sort of value. It's designed to be an alternate currency, but NFTs are designed not to be a currency. They're designed to be like artwork. And in times when there's plenty of money or inflation, times are good, these things can go sky high. But if there's a crash of some sort, nobody's going to want to buy it. But at the moment, NFTs are hot. All the young kids think they're amazing. People are collecting them. And, this Rario and Block Trust have done a deal with Cricket Australia. They're using all the buzzwords. I mean, one of the founders is talking about, we're establishing Australia's first sports metaverse designed for the Australian cricket community. I mean, talk about, buzzwords. And Block Trust says they've established itself as a leader in the development of bespoke NFT marketplaces. And look, if this is what people want, companies are out there, they're willing to provide these services. Cricket Australia obviously thinks that its fans globally, there's 1 billion cricket fans, are going to want to invest in these things. Some people think it's a giant scam. Other people will jump on board. And, I know people who made good money out of NFTs. And so clearly, some of these people seem to know a lot more than me. As a journalist, this is not the path to riches. Investing in NFTs seems to be a lot more profitable. So Cricket Australia is getting on board. There's all sorts of NFTs out there. Personally, I'd say, maybe invest in gold or silver or something physical. Not that I have any gold or silver, unfortunately, but at least the value of those things has never gone to zero. But a digital image that can be copied or somehow, faked, or you could be swindled out of, as has happened quite a lot with various NFTs, just doesn't float my boat. Doesn't make me want to score the 100 for Australia, that's for sure.
That's Alex Zaharov-Reutt from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.